Good morning, grade 11 students. Hope all are okay. I'm your math teacher, Wissam Sharafi. Today's lesson is also about numerical sequence. Today we're going to talk about geometric sequence. Last time we took the arithmetic sequence. Let's have a look about the sequence of numbers 3, 6, 12, 24, so on. There is a relationship between these numbers. Can you predict the relationship? Last time we took the difference between two consecutive terms and it seems to be constant in arithmetic sequence, while in geometric there should be another way. 3, then 6, then 12. To get 6 from 3 you multiply by 2. To get 12 you multiply by 2 and so on. So we can predict the 5th and the 8th term easily if you can find the common ratio. The ratio of two consecutive numbers, 6 over 3 is 2, 12 over 6 is 2, 24 over 12 is 2. The ratio is constant. Talking about the other series, we started with numbers we don't know, 9, 27, 81, and so on. Can you predict the relationship? So, we have 27 divided by 9 is 3. 81 by 27 is 3. Also, the common ratio here is constant, which is 3. So, it started with 9 divided by 3, 3, and 3 by 3, 1. The first one is 1, the second is 3, and so on. To define a geometric sequence, it is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero constant. We have consecutive terms. The second term will be obtained by multiplying the first term by a constant number. Usually we call it R, the common ratio. The sequence 2, 4, 8, 16, and 32. Here we have the first 5 terms of the geometric sequence. It is geometric, obvious. 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is 2, and the common ratio is. Suppose we want to find the 19th term. There is 2 ways to determine the 19th term. Either we keep on finding the numbers, which will take time, or we should end up with a formula that allows us to find the 19th or 20th or 70th or whatever term is. A geometric sequence, we want to prove that a certain sequence is geometric or not. In order to prove a geometric sequence geometric, or any sequence is geometric, we should use the general rule. And the general rule states that the ratio of two consecutive terms, any two consecutive terms, should be constant. If you find the ratio of, for example, Vn plus 1 and Vn, these are two consecutive terms, to be constant, then the sequence is geometric. Example 1, we have Vn equals 3 to power n. To prove it is geometric, then we should find a consecutive term other than Vn. Obvious, Vn plus 1 is 3 to power n plus 1. We find the ratio of Vn plus 1 and Vn, substitute 3 to power n plus 1 over 3 to power n. You have same base, you subtract the power, you end up with 3, which is constant. So we proved that Vn is a geometric sequence of common ratio R equal 3 in general. Another example is when we given, for example, U0 is 2 and U1 is half Un plus 3. And there is a sequence Vn which is Un minus 6. We want to prove Vn is a geometric sequence. To prove Vn geometric sequence, we find the ratio Vn plus 1 over Vn. If it is constant, then it is geometric. Vn plus 1, obvious, you substitute for n1, you'll end up with Vn plus 1 should equal Un plus 1 minus 6. And we have the value of Un plus 1, so you substitute. Instead of un plus 1, you put half un plus 3. You simplify, you end up with this value for Vn plus 1. You find the ratio of Vn plus 1 over Vn by substituting and simplifying to be half. Half is constant, so it is a common ratio, and the progression and the sequence is geometric. How to prove the sequence is not geometric is easier. We don't have to do it in general. It is enough to give a counter example. For example, you have a sequence un equals 3n minus 2. To prove it is not geometric, it's enough to give counter example. You find u0, u1, u2, u3, any three consecutive terms. Let's start u0. u0 you put for n0, you end up with 1. u0 is 1. Minus 2, it is minus 1. u1, it is 3 to power 1 minus 2, 1. u2, it is 3 to power 2 minus 2, 7. Obvious that u2 over u1 is 7 over 1, while u1 over u0 is minus 1. These ratios are not equal, so the sequence is not geometric. Another example to show that a sequence is not geometric is we have u0 is 1 and you have un plus 1 equals un over 1 minus 3 un. To prove it not geometric, as we said, you find three consecutive terms. For starting with u0, because we have u0 equal 1, starting with un equals 0 and 0, you substitute. You put 0 instead of n here and here, you substitute the value, you end up with u1 equals minus half. n equals 1, you end up with u2 equals minus 1 over 3. Obvious that the ratios are not equal, so the sequence is not geometric. Hope you understood, and this application will help you to memorize and emphasize the formulas. Thank you very much. Meet again.